Okay, hello, hi. It's Rani Ahmed with you, and this is lesson 4 in Haskell programming language. In this lesson, I'm going to talk about the truth values, how to create an infix operator, and how to use the bitwise operators to create test conditions, and also to write guards. There's something special to Haskell. Now, let's start. For example, when you want to talk about qualities, you use this form and then type x plus 3 equals 5. And when you just read it like this, you're thinking of solving an equation that will lead to finding x equals to 2. Now, this does not work in Haskell. The single equal sign means to assign a value. Okay, for example, I have a box, I assign it some apples or some oranges, something like this. So it's set like this. But here it does not work like that. You have to put a double sign equal, just equal signs, just to make a test whether x plus 3 is 5. Okay, and we'll see the result whether it's a true or false. Okay, so let's say let x equals 3. Okay, oh sorry, so let x equals 3. Okay, and let's test if x plus 3 equals 5. So this single equal does not work. As I said, you have to put it a double equal, so it will give you a false. Okay, now so if I said again let x equals 2, now it will give me the equality as 2. Now other operators for equality, you've got the, let's say there's x plus 3, for example, greater than or equal to 5, less than or equal to 5. Okay, and also you've got not equals to 5. Okay, you think about it, you get the results, you know why it's true or false. Okay, now this is how we do testing for equality. Now, how do we create our own infix operator? Now, before I talk the infix operator, I'm going to talk about why do we say infix. Okay, there's something called in English. Okay, you have something, for example, there's the suffix. Okay, there's the prefix. Okay, they are not just the re or the ly. Anything similar to those are called suffixes and prefixes. Why? Because you have the word sudden and you attach to it to the end, to the last character, something like the ly. So it change the meaning. Okay, and if you add a re, okay, for example, this is a prefix. This comes at the starting letter of the word. Okay, and infix is something in between. Okay, so if I have two arguments here, that's why we use the infix, the preposition in. So the x here with the infix operator, the hashtag, and y. Okay, I want to define it. I want to define it. There's nobody can stop me. Okay, I want to define that x hashtag y is equal to x plus 5 times y. Now it's preferred that, or it's better that you define such operators in the file and load them. Okay, and the way you write them is by defining the symbol, and the symbol has to be non-alphanumeric character. Okay, with the infix operator symbol, it has to be a non-alphanumeric character, and you start it and you put it between parentheses like this, and this is the left side and this is the right side argument. Okay, similar to x here and y here. Okay, and then this together, all this will look like a normal function, something like what I used to do in my func or something like this. Okay, and this is the equal, this is the return value of that operator. Okay, now if I load the file test.hs, which I'm using, So if I want to say like 3 hashtag 4, it should give me 23. Okay, try any other numbers, maybe 1. Okay, 21, of course. So this is an operator of my own making. Okay, now what about the rest of the operators? Okay, so for example, here, what's the OR and what's the AND? Okay, those do bitwise operation. Okay, so what's true and false, what's true or true, true or false, things like that. How do you calculate them? Okay, now the AND, okay, is always true when both are true, otherwise they're all false. Okay, both sides are true values. They give you, like, if you test the cases, okay, something like this. Okay, both cases, okay, it will give you true. So both, if they are both at the same time true, okay, it will give you true. Otherwise, if they are true or false, true and false, it will not be true. It will be always false, and together as false at the same time give you false. Okay, and the OR is the opposite of the AND, complete opposite. Okay, so let's say I have 3 greater than 4, okay, and I mean or, okay, 3 let's say 7 less than 18. Okay, this will give you true. But if I do it as like AND, it will be false, because true and false cannot exist at the same time. So this is how you use it. And there's also, if you want to make the negation, okay, if I say like not this, okay, if I want to say the not, okay, I use the not, and for example 3 greater than 4. So not of 3 greater than 4, 3 is less than 4, it's not greater than 4. Okay, but 3 as is here, as it's written here, okay, this will give me false as a value, and multiply it with a not, okay, it will be a false, a true, sorry, it will reverse the value. Okay, so so this is all about the bitwise operations, okay, and use them later with if statements and things like that to make test cases, okay, for your conditional statements. Now, if I want to make something like what we call gods, what if I have a function that has a number of situations, okay, similar to what you see maybe in this form, okay, of writing. You have, I'm here talking about the absolute value. This is the definition of the absolute value, okay. You have so many conditions and you put them in a big left brace, okay. So this is how you write this left brace in Haskell code. You type the name of the function, okay, you put the parameters that you want, and then you put a tab, and then put a pipe, and then put the condition, okay, and then the equal, okay, just to say the, of course, just to say the return value at this condition, okay, and you repeat as much as you want of such cases, okay. This is a whole one case, and you finalize it with an otherwise, okay, just to say what will happen if otherwise, okay, if you want to add an otherwise value, okay. Now let me load the file. The file has been loaded, sorry. So I can use my func, okay, and type 3, okay. This gives me 3 because according to what I've coded here, okay, the 3 is between 1 and 5 strictly. It will return the value of x, which is 3, okay. Now if I want to put like 13, it will give me the negative of 13, because this is otherwise greater than 5. And if I want to talk about things which are negative, okay, I have two ways to do it. Either I say let x equals minus 2, okay, and then I say my func as x, it gives me minus 6, or I can use like this, -2, okay, gives me -2, and like this also -6, okay. This also works. Cool. Just did not understand what about this, so it did not work. Okay. Yeah, because it does not match. Okay, this does not match. But just understand, you have to put it in as a negative. You put it like this, okay, as a parameter. So that's all about Haskell, and you're welcome. Please share the videos and tell the people about them. Okay, thanks.